Hello. So we've got another systems of inequalities practice problem here, and this one, I was so rude. I did not give you either of them in y equals mx plus b format. You can, of course, switch these into y equals mx plus b form, and I will show you that method in this video. In another video, I will show you a method for dealing with this same problem without switching them into y equals mx plus b form. So first one, if we're going to switch it to y equals mx plus b form, what we're going to do is subtract 40x from both sides. So then we end up with negative 10y is less than or equal to negative 40x plus 60. Notice all you have to do is move the x to the other side of the equation. And how do you move it? By doing the opposite to both sides. That is the key idea when you're working with something algebraically, is if you do the opposite to both sides, you still have a valid equation. Still have a valid inequality in this situation. So I subtracted 40x from both sides. I did not combine it with the 60. I left it as a separate entity from the 60. Now I'm going to divide everything by negative 10. If this was an equation, everything would stay exactly the same. But it's an inequality, so we need to keep track that when you divide by a negative, it switches the direction of the inequality. Pay attention to what just happened. We had a less than problem that became a greater than problem. Now I have it written in mx plus b form, so I can identify my m is 4, my b is negative 6. I can put a dot here at negative 6. I can count up 4 and over 1. Up 4 and over 1. I can connect my 3 dots here. Think about why I drew a solid line. Make sure you've watched the first video. If you need a reminder, I drew a solid line. I drew a solid line because it is or equal to. It does not just say greater than, but it also says or equal to. I'm going to shade everything above the line because these points have a y value that is greater than that. Some of you may be thinking, wait, that's on the left side of the line. It is also above the line. If you put your pen on the line and go up, you will hit the shaded region. If you put your pen on the line and go down, you will not hit the shaded region. I want to shade above because it's a greater than symbol. Now I'm going to take the second inequality in a different color. Take this inequality, add 4x. If you do the opposite to both sides, then you move the x's to the opposite side. So I have positive 4x plus 24, divide by 8, divide by 8, and I get y is less than or equal to 1/2 x plus 3. Let's see if I can find 3. It's a little bit hard to count. There's y equals 3. Then I go up 1 over 2, up 1 over 2. I connect these dots as well with a solid line because it says less than or equal to. And I shade everything below the line. The purple region is the important part. The purple region is the part that was double shaded. It looks something like this. I'm going to choose a point that was shaded by both of those inequalities. It looks like negative 5, comma, negative 5 is right in the middle of that purple zone there. If I test my point out with the red inequality, I would be saying 40 times the x value minus 10 times the y value. Is that less than or equal to 60? That gives me negative 200, and this gives me 50. Well, that definitely is less than or equal to 60, so it checks out for the red inequality. Then we try it with the blue inequality. Is negative 4 times the x plus 8 times the y, is that less than or equal to 24? Well, let's see. Is 20 minus 40 less than or equal to 24? Yes, it is. So we found a solution to both. So in my next video, I'm going to do the same problem, but I'm going to do it without switching them into y equals mx plus b form.